Hi everyone! Today we are going to talk about what functional programming is. There are several definitions. Some people say that a language is functional if it supports Val functions, or in other words, when functions are ordinary objects. Indeed, in the first chapter, we saw how Val functions enable many functional programming patterns, such as when we pass functions as inputs to other functions. However, Val functions alone are not enough. We also need to program with a particular kind of function. And this is where some confusion arises, because the word function can mean something completely different depending on your programming background. For example, in imperative programming, a function is more of a procedure, like a list of instructions to execute sequentially, such as creating or assigning a variable, calling another procedure, or exiting the function. In a sense, we could rewrite any imperative program by expanding all the functions inside it, which will result in a gigantic file with each instruction executing one after another. On the other hand, in functional programming, a function is a transformation from inputs to outputs. And an FP program can be seen as a pipeline of transformation, connecting one function to another. Therefore, the output of one function becomes the input of another function. Another way to look at this is to visualize an FP function as an immutable map, where we have the extra guarantee that every possible input is covered. Let's have a look at a few examples. Say we have a function getUserAge that takes a user and returns an int. Here we can see that the user Elise is mapped to the number 34 and Bob is mapped to 52, representing their respective ages. This function is equivalent to a map with two entries, one for Elise and one for Bob. One thing to notice is that several users can return the same number. For example, we could have Elise and Zoe who both point to the number 34 because they are both 34 years old. Another implication is that some output values are never returned. For example, we don't have any arrows pointing to the number 427 because we don't have any users age 427 years old, at least not yet. Now, I'm going to present three restrictions that all FP functions must satisfy. These requirements may seem very constraining, but I will ask you to take a small leap of faith. In this video, I will describe those restrictions before going through a short quiz to ensure we are all on the same page. Then, in the next few videos, I will present why those limitations are crucial to building powerful, reliable, and extensible applications. The first difference between an FP function and other definitions of functions is that all inputs must return an output. For example, in this case, it's impossible to have a user from whom we don't know their age. In practice, this means if we pattern match on the inputs, we must cover all the cases. For instance, if we define a function toInt on the JSON enumeration, we would get an exception if someone calls it with a JSON string. This is because the pattern match is not exhaustive. More generally, functions in FP cannot throw exceptions, because when they do, it is the same as saying this particular input is not supported. But by definition, an FP function must produce a valid result for all inputs. The second limitation of FP function is that the mapping between input and output values is static. An FP function is like an immutable map. This means that a function called today will yield the same result tomorrow or in 10 years, as long as we provide the same input. This is another strong restriction. Let's go back to the getUserAge function as an example. Today Zoe is 34 years old, so the function returns the number 34. But because the mapping is immutable, getUserAge will also say that Zoe is 34 years old in 10 years' time. This may seem like crazy, but we don't manipulate real objects in programming. When we get an instance of the user class, this is a snapshot of the modelization of a real user. And when we say that the user Zoe is 34, what we mean is that when we created a representation of Zoe, she was 34 years old. The snapshot is immutable, and that's why getUserAge will always return 34 for this specific instance. Finally, the most important limitation is that an FP function cannot perform any actions. For example, it cannot call a web service, fetch data from a database, or even print a message to the command line. If we come back to the map analogy, we can see that a function cannot interact with the external world. The only thing a function can do is return a value. One sign that a function performs an action is if it returns unit. Unit is a very special type from the standard library. It's a type which contains a single value, the empty parentheses. So if an FP function were to return unit, we would know its exact implementation. It should be a map where all inputs return the empty parentheses. In other words, it should be a constant function. In practice, a Scala function which returns unit is a procedure used for taking actions in the external world, as we can see here with create new blog post and audit log. To summarize, an FP function must respect the following three rules. 1. It must return a value for all inputs. This means we cannot throw exceptions. 2. It must be static. This means that for a given input, we always get the same output. 3. It cannot perform any actions. The only thing a function can do is return a value. These characteristics are also called total, deterministic, and pure or without side effects. We'll see in later what does it mean. Okay, now that we have seen what a function is in the functional programming world, let's go through a few examples to determine if they are or not FP functions. First, we have an enumeration that encodes all days of the week, such as Monday, Tuesday, Wednesday, until Sunday. Is the function isWeekend an FP function? Please pause the video and take a minute to think about it. Yes, it is an FP function, because isWeekend is equivalent to the following immutable map. Every input is covered, the mapping is immutable, and the function doesn't perform any action. Next, we have a class blogEntry containing a UUID, a title, and a publication date. Is the function createBlogEntry an FP function? Please pause the video and think about it for a minute. No, it isn't. createBlogEntry is non-deterministic. If we call the function several times with the same title, we will get different results. This is because random UUID returns a different ID each time. LocalDate.now is also non-deterministic, since it returns a date when the function is called. So if we run the function tomorrow, we expect to get a different result. In the next example, we have a class with the method addUser, which inserts a row in the user table using an SQL query. Is the function addUser an FP function? Please pause the video and think about it. No, addUser is not an FP function because it performs an action. It contacts a database and executes an SQL query there. One sign that addUser performs a side effect is that it returns a future of unit. And as we saw earlier, unit is a type with a single value the empty parentheses, which means that it doesn't carry any information. Finally, there is max, which computes the largest number in a list, returning none if the list is empty. Note that max uses a mutating variable to store the largest number it has found so far. In your opinion, is max an FP function? Please pause the video and think about it. Yes, it is an FP function. All the inputs are covered, and for any given input, the output is always the same. Finally, it doesn't perform any visible action. It does update a mutating variable, which is an action. However, this variable cannot be seen outside of the function, meaning that we could rewrite this method without the variable, and nobody could tell the difference. The mutation is merely a detail of the implementation. Great! Now we have a good understanding of what a function is in the functional programming world. It's essentially an immutable map between input and output values. This means that an FP function must satisfy three properties. It must be total, deterministic, and without side effects or actions. Those restrictions are significant, which means that we'll need to change the way we code. This will be the subject of the next two chapters, in which we cover how to perform actions and handle errors. However, before we dive into these techniques, I believe it's crucial to first understand the motivations for imposing those limitations in the first place. This will be the subject of the next few videos. I suggest that we take a break now, and I will see you soon for the next episode. Bye! Don't forget to check out my website, fp-tower.com, to get access to all my functional programming content and sign up for my course. See you soon!